How you doing, neighbors? Uncle Lee here. Another discussion about polar coordinates. For most of us in calculus, this should be a review, but a much needed review about polar coordinates. Polar coordinates part 1. Polar coordinates are yet another way to describe a point in XY land. That's what polar coordinates are used for. Say we have this point right here. This point is in XY land, 3, 3. I got an X coordinate of 3 and a Y coordinate of 3. How can I describe that point using polar coordinates? Well, let's see here. Let's go to the next slide here. What we're going to do here, whoopsie, hello. What we're going to do is the R, we're going to describe that thing with an R, comma, a theta. And R is going to be the length of that segment from the origin to that point. Theta is going to be the measure of the angle from that segment to the positive x-axis. And that's how I'm going to describe that point in polar coordinates, r, comma, theta. So if r is the length, how do I find length in xy land? I'm going to use Pythagoras' theorem, which is going to tell me r squared is going to equal this x value squared plus that y squared value squared. Therefore, r is going to be the square root of 3 squared plus 3 squared, or the square root of 18. Easy enough. Don't forget what you've studied in the 5th grade, Pythagoras' theorem. Well, how do I find this theta right there? Hey, let's use some basic geometric definitions of trigonometric ratio. And we see that the tangent of theta, the tangent is defined to be the opposite over the adjacent. The tangent of theta is opposite over adjacent. This time the opposite length of this triangle, and we're looking at this triangle right here. Looking at this dude right there. Or this particular length here is 3, and that length is 3. So then the tangent of theta is going to be opposite over adjacent, which is 3 of 3, which is equal to 1. Therefore, theta is the inverse tangent of 1. And we know what the inverse tangent of 1 is going to be pi over 4. Okie dokie. Here we go. Let's do another example right there. Well, before we do another example, let's define a few things about polar coordinate system, about the polar coordinate system. A few definitions that we need to know. We need to know that the pole corresponds to the origin. So when I speak about the origin in polar coordinates, I'm going to call it the pole. The polar axis is simply the positive x-axis. R is the distance. R, sometimes known as the radius, no, all the time known as the radius, is the directed distance of the point from the pole. And this is going to be very important. Directed distance. What the heck does directed distance mean? We'll get to that in a moment. The directed distance from the point, of the point from the pole. And then theta. Theta is the positive angle from the radius to the polar axis. And what is interesting about polar coordinates is that r and theta both can be negative. So let's do a couple examples right here. Let's graph the point 3, comma, pi over 3. Keep in mind this is our r. Change the color of that rascal. This is our r and this is our theta. And it's always best to start out with theta. Know how far around you're going to go. Positive angles, measure counterclockwise. And so I'm going to go up pi over 3 radians for that angle. And then what r is, I'm going to go out 3 units. 1, 2, 3. I'm going to go pi over 3 angles, out 3 units. This gives me that point 3 comma negative 3 comma pi over 3 in polar coordinates. Let's graph another point in polar coordinates. Let's graph negative 3 comma 4/3 pi. Again, always best to start with theta. We're going to 4/3 pi now. Going to 4/3 pi. So I'm going to 1/3, 2/3, 3/3, 4/3. So I'm going to go around to 4/3 pi right there. And then what this negative r means is that I'm going to direct a distance. So if I'm at 4/3 pi, as I am, that's theta. I'm not going out this way, because that would be positive directed distance. What I'm going to do is go negative r, so I'm going to come here, and then I'm going to go negative opposite of 3 units. So I'm going to go negative 3. So I'm going to go to 4/3 pi, and instead of going positive 3 out, I'm going to go the opposite direction, and that's going to give me the point negative 3, 4/3 pi. And that should be interesting, because what point is that? Well, that is also 3 comma pi over 3. Same daggone point. Same point. So, unlike points in the xy coordinate system, the points in xy coordinate system can only be described by one x and one y. However, any point in xy land can be described with infinitely many polar coordinate forms. You can notice here also that 3 comma negative 5/3 pi is the same point. Go to negative 5/3 pi, 1/3, 2/3, 3/3, 4/3, 5/3 in the opposite angle direction. I'm out here 5/3 and I go out 3. 3 comma negative 5/3 pi. Next slide, please. Hey, what if I had to figure out, what if I want to convert these polar coordinates to rectangular coordinates? A very useful procedure. Well, let's see how we're going to do that. I want to convert that point in polar form. This is an x, pardon me, this is an x theta, r theta, pardon me, why I get my terminology straight right there. That's an r theta, 3 comma pi over 3. I want to say, hey, what is the xy coordinate what xy coordinate is associated with that point? Well, what I'm going to do is I'm going to pull that right triangle off the grid and look at that dude. And what I want is this x and this y. And I notice, and this is very important, that I'm in quadrant 1. And when I'm in quadrant 1, x and y's always are positive. I have a radius of 3, and this angle is pi over 3. Again, I'm going to use the geometric definitions of the trigonometric ratios, which is going to give me the cosine of pi over 3. I can use sine, or well, I'm going to use cosine of pi over 3. And what is the cosine of pi over 3? Well, the cosine is adjacent over the hypotenuse, so cosine of pi over 3 is the adjacent, which is x, divided by the hypotenuse 3. And I want to find x, so I simply multiply cosine pi over 3 times 3. Cosine of pi over 3 is 1/2. 3 times 1/2 is 3/2 x. So this x value then is 3/2. How do I find the y value? In like a manner, the sine of pi over 3 is y divided by 3 is the opposite over the hypotenuse. My objective is to find y. Simply multiply by 3, and y is going to be 3 times the sine of pi over 3. The sine of pi over 3 is square root of 3 over 2. So this is going to be 3/2 square root of 3. So that's going to be the y coordinate. 3 pi over, pardon me, 3, what the heck? Sorry. 3 square root of 3 over 2. 3 square root of 3 over 2. That's the xy coordinate that corresponds to the polar coordinate 3 comma pi over 3. one and only one xy coordinate system that corresponds to coordinate point, one and only one xy coordinate point that corresponds to this polar point. Infinitely many polar points can describe that point right there. What if my question was, say I had the point -2, 3 in xy land, and I want to convert that to polar coordinates. Well, what am I wanting? I'm wanting this r and that theta. I want that distance and that theta. That's what I want. And I notice now that I'm in quadrant 2. This is going to be very important. Well, let's see. What I'm going to do is that I'm again going to consider this right triangle that has this distance and this distance. Now, this distance we're going to consider to be positive, because what I'm going to do is I'm going to pull that right triangle off, and I'm going to look at that right triangle. And I want to find r, and I'm going to use alpha right there, because I eventually want to find theta, but I'm just going to consider alpha. And this is the easiest way to do this. There's other ways to do it. This is a fairly straightforward way. Well, I have this little right triangle right here. Hey, again, I'm going to use Pythagoras' theorem, where r squared is 2 squared plus 3 squared. Therefore, r is square root of 13. And then the tangent of theta is going to be, the tangent of this angle right there is going to be opposite over adjacent, which is 3/2. Therefore, alpha is going to be inverse tangent of 3/2, which, rounded to 5 decimal places, 0.98279. It's not the alpha that I want. It's this theta. What the heck is theta? Well, theta then, hello, theta is going to be pi minus alpha. Pi minus the alpha is going to be 2.156. So this is the polar form of this xy coordinate point, -2, 3. I think we're going to stop it there. This is going to be the end of polar coordinates part 1. We'll continue with the polar coordinates part 2 and look at some graphs of polar functions. Thank you.